In this lesson, we're going to take a look at how to simplify rational expressions. So if you look at the first example, we have negative exponents. Now, typically when we see negative exponents, the first thing we think is throw them in the denominator. However, in this case, we're actually going to factor. So before we get into factoring with negative exponents, I want to remind you what that would look like if they were positive. So let's pretend we had x squared plus 5x to the fourth. When we're looking for the GCF, we would take the term with the smaller power. So x squared would get factored out, leaving us with, remember, we're dividing. X squared divided by x squared would be 1 plus 5x squared. The way that we divide powers is we took 4 minus 2 to get this 2 left over. We're going to do the exact same thing with our x to the negative 2 plus 5x to the negative 4. But working with negatives tends to be a little bit trickier than working with positives. So stick with me. And we'll see this 3 times. So hopefully by the 3rd time, if you're a little lost on this one, it makes a little more sense by the time we get to the end of this page. Now when we're working with negatives, the bigger the number looks, the smaller it is if it's negative. So negative 4 is smaller than negative 2. So we're going to factor out x to the negative 4. Again, when we factor, we're dividing, which means we're subtracting the exponents. Negative 2 minus negative 4 is the same as negative 2 plus 4. So we get x squared plus 5 left over, because that x to the fourth came out, or got pulled out when we factored. The last thing we need to do is make sure that we don't have any negative exponents, so we're going to create a denominator to put that x to the fourth in, so that exponent becomes positive. The second part of our directions were to state the domain. Now in this case, when we have a denominator, we have to be careful that we don't have division by 0. So we just set whatever the denominator is equal to 0 and say that's what x cannot be. Well, in this case, x cannot equal 0 because that's the only time that x to the fourth would equal 0. All right, our second example, we not only have negatives, we have fractions, which makes it even more fun. So process is the same. Look for the smaller of the 2 powers, which is the negative 5 halves. The coefficients don't have a common factor, so it's just x to the negative 5 halves for our GCF. So the first one, we're just left with 3. And again, we're subtracting, and because these are negatives and fractions, I'm going to show my work off to the left here. So we're going to take negative 3 halves minus negative 5 halves, because remember, we're dividing by the x to the negative 5 halves. So adding the opposite, we get negative 3 halves plus 5 halves, which is 2 halves or 1. Again, simplifying that negative exponent, we're going to throw that in the denominator. And our domain restriction, x cannot equal 0. So that's the only time x to the 5 halves would equal 0. All right, one more. It's looking a little bit more complicated, but notice this term is our GCF. We just have to find the smaller power, which in this case is that negative 3 halves. So that leaves us with x on the first term, and on the second term, we're going to, again, I'll show my work over here, taking negative 1 half minus negative 3 halves, which is, again, 2 halves, or 1. So that's simplified kind of nicely. So I'm going to do 2 things on this one. I'm going to simplify what's left in my numerator while I move my negative power term to the denominator. So this mess right here is my numerator, so I'm going to simplify that to 1 minus x. And then we've got the 1 minus 2x to the 3 halves power in the denominator. All right, finally we're going to take a look at our domain restriction on this one. So we set 1 minus 2x to the 3 halves power, not equal to 0, that's our domain restriction, or equal to 0 if it's easier for you to think about that instead of the not equal to. To cancel that 3 halves power, we're going to raise both sides to the 2/3 power. Well, nothing happens when you raise 0 to any power, so we simplify to 1 minus 2x cannot equal 0. adding 2x to both sides, and dividing by 2, we get our domain restriction. Sorry, I put a 0 there. That should most definitely be an x. So there's our domain restriction.